conveyors, and conveyor is one of the key component in material handling system. So we talk about different type of conveyors. They're like wheel conveyors, roller conveyors. So one in that is the most important thing, that is the chain conveyor, trolley conveyor, powered and free conveyor, tow line conveyor. Might you have seen this one in warehouses where the tow line conveyors are frequently used every year in warehouses. So these are the different types. Now come to the furthermore, the sorting conveyors. So in sorting conveyors, basically the sortation of different components laying on the conveyor are taken place. For example, based on the size, based on the barcode, so it will take different paths where you want to divert your desired product. Similarly, you have the deflector. The deflector, you basically deflect the movement of parts in a certain direction. Sliding shows sorter. Similarly, the push diverter. In push diverter, you provide an external push to the material, and then it takes the right path in right direction. Tilt tray sorter, pop-up wheels. Pop-up wheels mean there will be certain wheels inside the conveyor, and it will only pop up when you want them on a certain time. Similarly, pop-up rollers. So like wheel, there will be at some point inside the conveyor, there will be certain rollers. When you push the button, so it will come out and it will transfer the material only whatever you want to desire. Similarly, you have another type of conveyor, that is the tilt slate conveyor. It's like a slate conveyor, but it's the different direction, they are tilted. So this type of conveyor is very rarely used in warehouse and industries, but in very customized way where you need the angle for different type of components and you want to perform some assembly operation on the conveyor. So in that case you have to use this tilt salt conveyor. Come to another slide. Industrial vehicle. This is another component of our material handling system. So in industrial vehicles, these are the walking tools, hand truck and hand cart. You have seen these. Like in previous year, your senior had developed this type of cart. This one is the hand truck. You can push it. Pellet jack. So here you have the jack and which carries the pellets, and using the jack you can easily remove and place somewhere where you want. This one is the walkie stacker. Walkie stacker is also like a jack, and it is used for handling the heavy material and heavy packaging. Industrial vehicle, if we come to further more complicated one, so this is another pallet truck. Like previous we talk about the hand one. This one is the automated pallet truck. This one the platform truck, counterbalance lift truck, tractor trolley. So these are the different types, but it's based on the circumstances that where you need and what type of environment you are working. So in that particular case, you have to choose, but it is based on the conditions. For example, somewhere you need this type of counterbalance lift truck. For example, in parking, the people are using this one. They cannot use this one. So it based on the condition and its application. So industrial vehicle trucks, they are basically lift truck. They are popular and they are very flexible because the complete machine you can move it from one place to another. So, but we talk about its cost and its safety and its the space utilization, because these are the important factors which decide and which help us that whether the lift truck is useful in that particular case or not. And then again, because it cost and the fuel cost is quite high if you are using frequently this type of lift truck. So you have to choose very carefully that what type of fuel type truck you are using, for example, the electric one, the gasoline one, the LPG one, the propane fuel cell technology one. Then again, you have to use the tire types, that what type of tire you want, whether this one be cushioned or pneumatic, the lift capacity. So this one is the design capacity basically, that for what type of, what material type you are. For example, you want 1 ton unit load, you want to move from one place to another. So then you choose, at least with the factor safety, let's say 1.5 ton of lifter. Similarly, the attachment options. The attachment, that is the another accessory you use with the trucks. And attachment is based on the condition, that what sort of condition you are working in. For example, if you are working in the parking, so then those toe type with the two long rods, so you will use that sort of lifter. While in other case where you deal and you are working with the big cottons, so in that case the complete plate will be required for handling the material and handling the load. Another industrial vehicle and lift truck, that is the standard forklift, reach truck. So this reach truck, basically if you are working at numerous height, so for in that case you have to use this reach truck. So maximum you can reach up to 10 meter, which is quite a high place. Order selector truck. So order selector truck is basically you are using in warehouses. So it can reach up to height as well as, but it can take its path very narrowly, and it can follow the narrow paths and narrow places, and then easily you can place your order, and the truck will go there and it will load the order and will deliver it to the desired position inside the warehouse, not outside of the warehouse. So keep in mind that apart the traditional system, nowadays we are working with the automation. Definitely nowadays, like in COVID-19, the need of automation has been raised, and industries for material handling, they are using these automated vehicles for a long time. So automated guided vehicle is one of the main component of material handling system. So they are usually battery powered, they are driverless, they follow the destination. You program the destination, you program the path, you give the machine a path, you give a position to it, and then it develops its own capabilities based on that program, and it work on that program regardless of any human intervention. Used to transport material from It is used to transport the material from various loading location to unloading location. It avoid the intelligently. It avoid the collision. Okay, so you basically, once you design the path and you give path to automated guided vehicle, so the basic theme of the program should be that it avoid the collision. It must not be collide with each other. It will waste the money and it will waste the time and machines when it collide with each other. So the communication is quite sustained through the radio signals. Mostly we use the radio signal and color detection. Once you give it path, so it detects the color. So every AGV identify its own color, and then it follow that color and go and follow that path. So there are different types of AGVs, like the conventional material handling, like the lifts, different types of lifts we are using. So towing vehicle. So in the front we have the AGV, and we have towed different trolleys behind this AGV, and it follows its path and it give travel to these trolleys. It could be a unit load transporter, like in this one, unit load AGV, if you can see here down. So, and the other one is the assembly AGV. In assembly AGV, it is particularly used in automotive industries. For example, if you go to the Honda or Toyota company or different various assembly points, so it has a complete AGV, and different components come on top of that, and the people come and they work on that station. So that station is known as the assembly line vehicle. So it takes the load as a complete package, not as an individual component. Then we have different sort of cranes. So monorail, hoist and cranes. So you are familiar with these type of cranes. For example, the monorail, if you have gone through the internship, so in heavy industries, wherever you work, like in the locomotive one and in the heavy mechanical complex, HIT, cement industry, so they are using these hoist, monorail, jib crane, bridge crane, gantry crane. So they have specific parts, but these are very expensive and they are difficult to operate, and they are expensive component and heavy to invest initially. After the material movement, then the storage come. That where we have to store the different materials. So it is the basic requirement of storing the material. Either it could be a finished product or it could be the semi-finished or raw material. So you have to store these at different points inside the plant. So for that case, the common one is the pellet racks. It is very common. We are using this like in our labs. Pushback racks. So pushback racks are like the cupboards. So these are cupboards. You drag these cupboards, keep the material. If they are like tiny material, you can use your hand, but if they are heavy, so then you use these lifters. Flow through rack. So flow through rack are basically, you flow the material, you flow the load at one point, and it takes its path and then it go to the another location. Let's say, for example, if you are pushing the material here on top, so it will go to another chamber and then another chamber, and then at this point at down of the chambers you can collect it. So it is based flow through racks, basically the first in and first out. So whatever material artwork, whatever package you keep it first, so then it will come out first, because you are pushing the material behind this first one. So once you push, so the initial one will come out whenever you need. So this one is the material storage and retrieval equipments. In this category, then we have another one like the drive-in and drive-through. So drive-through is basically first in, first out, and drive-in basically late in, first out. For example, drive-in is the drive-through mean that it will take a complete path and it will through different chambers and will reach to the point where you can collect it. While drive-in is the there is no through way. You have to push the material, and whatever you push at the later stages, you can collect that at first. So this one, these are the two storage and retrieval equipment systems. One is the drive-in, it means late in, first out. Drive-through, first in, first out. Then we have the cantilever rakes. So the cantilever rakes is very simple one. If you have gone through the various steel shops, so these people are using these cantilever rakes. They have inserted these rakes along the walls, and they keep different steel material inside these cantilever rakes. There is another category. These are the conventional, what we talk about. Another one is the automated storage and retrieval system. In automated storage and retrieval system, basically unit load automated storage and retrieval system, man on board automated storage and retrieval system, Main on board means if you have seen the automated car parking. So in automated car parking and multi-story car parking, you basically put your car at one point and there is a man who use different buttons, and then he take that car to a different location and keep it at different floor for you. So these are the main on-board automated storage and retrieval system. Mini load automated storage and retrieval system. Mini load automated is basically you are dealing very tiny parts. So in that case, you are using, like if you have gone through the mobile shops, mobile repair shops. So what they people are doing, they basically put these type of mini load automated storage and retrieval system. There are different small racks and they quote the information in front of that, and then they keep these tiny parts in those mini load automated storage and retrieval systems. So these are certain examples. You can go and you can see with the different angles that we are and how we are using these storage compartments in different applications. Small load storage and retrieval equipments, these are the horizontal carousels. Horizontal carousels mean it moves like in this. Horizontally you keep these and you can rotate. If you have seen these type of particularly we can see these in the garment shops. So like in garment shops, you can use this concept for your material storage and retrieval. You have different racks and different compartments, then you can rotate these in a circle. So these are the horizontal carousels. In horizontal carousels, you can keep and you can very easily bring that retrieval for you whenever needed. So similarly, we have the vertical carousels. So these vertical carousels are particularly nowadays they are using for the automated car parking, multi-story automated car parking. And we are using frequently these in the industries like electronics industries. So in electronic industries, we are using these vertical carousels. These vertical carousels basically consist of multi-story, and in that multi-story then you can rotate it vertically. You can rotate these compartments vertically and you can use it for storage and for retrieval. Automatic identification and communication equipment. You can identify and you can communicate with the storage material and storage devices. These could be either with the barcoding and optical character recognitions. You can provide some characters to that. Let's say, for example, for mirror, if you are storing mirrors at some point, so you can give it M. If you are storing the screw, so you can, let's say, for example, give some characters S, C. So the barcode are used and some characters you can use for that. You can communicate with the automated material handlers which are taking the material from one location to another. So you can use a paperless communication with them. That one is the radio frequency data. So through radio frequency, you can call the AGVs. It will take the right material by reading the barcode or identifying the character, different characters. Then you can also call it with the voice headset, like you can see these voice headset. Nowadays we have these features in our mobile as well. Light and computer aids with the smart card. So the smart card are also used. You can insert these card at different location and it can trigger the different lights and different voices for identification of the material and for identification of the right material handling device. Let's say the AGV or any forklifter, you can call it. The equipments, the next important thing of this complete series of material handling devices and storage compartments, the important thing is how to select the equipment. This one is the question. And it depends on the selection is basically depends on the what you want to move. So it is related with the material you want to move. what type of movement you want. Whether you want a vertical movement, either you want a horizontal movement. What you want to store. So the storage is the key parameter where you can decide that what particular system is required for you. The cost, that how much you can purchase, what should be the cost of that, your pocket, the worth of your pocket. On top of that, then we have to choose based on the adaptability, flexibility, load capacity, the power use. If let's say the material handler is very easy, but very cheap and easy to operate, but the power consumption is quite high, so it's not good for us. The speed, the space requirement, that how much working envelope it required to handle the material. Then the supervision required. Definitely we will prefer a system which doesn't require more supervision. It could work independently. So you have to decide about the supervision, that how many people are required to supervise a single material handling, storage and retrieval package. Ease of maintenance and the environment friendly. It should be environment friendly. So the equipment selection, basically in material handling, we are using the conveyors, trucks, cranes, and we have to choose these based on the if you look through the this model, so you material flow requirement, that what are the requirement, what is the load of that material you are dealing with. The technical feasibility, feasibility comes with the working envelope, basically its maintenance, the people required to supervise, the space the machine use. So then you go to the material handling equipment database, because I have talked about the standardized equipments, not very customized one. First go to the standardized one. So if you are going to the standardized one, then you have to go to the database of the equipment. So you go to the database, material you want to deal with, it will enable you to develop a technical feasibility of your material handling system. And once you develop your technical feasibility, for example, the supervision, its power use, the material handling capacity, let's say 1 ton, 2 ton, then you can say that how much it will cost me. Whether it will cost me 1 million, 2 million or 3 million. Can I afford that? Then you can choose that whether that material handling is suitable for you or not. So this one is the standard selection report. If you are working as a manager in any plant and you are choosing, and your task is to devise a right material handling equipment for the plant. So in that case, you have to work based on this model. So if you are working on this model, then you can devise and you can produce a right report for presentation and to show it with the higher ups. Material handling equipment, you have to answer certain questions, and the people will ask you. The people can ask you different parameters. These parameters are particularly associated with the material handling. For example, with the material handling slash labor, you are working with the material handling. What is the ratio of that? Okay, material handling, the equipment you are using, and the personnel assigned to that one. So what is that ratio? So personnel assigned to the material handling and the total operating personnel. So if the ratio is, let's say it should be less than 1. If the ratio is less than 1, then it's okay. But you have to keep it less than 0.3. So this one is the simple fingertip for you. If you are working in any industry and you want to show the selection, the right selection, whatever you devise and whatever report you produce for the your director or someone, so you have to show him that what is the material handling ratio. So this material handling ratio, if it is less than 0.3, so you are safe, and this one is the right and suitable material handling system for your plant. There is another parameter you can say about that. That one is the handling equipment utilization. Handling equipment utilization. Yeah, it means the equipment you are using for handling the material, either for taking its motion from one place to another, or for storage and retrieval. So what is the utilization ratio of that? So if you are talking about the utilization ratio of handling equipment, so in that case the items are load you are moving per hour and the theoretical capacity. For example, the theoretical capacity is, let's say it can carry 1 ton load in 1 hour, but practically it cannot. It can carry only 700 kg load per hour. So then you have to calculate that. Ideally, it will be better and better if it is very near to the 1. If it is 1, so it is very ideal. But that's not possible, because the material handling equipment, it can break down, it has the breakdowns, there could be some fuel shortages, there could be some sudden stoppages. So because of that, the ratio will be less than 1, but it will be better if it is close to 1. So you can say about the handling equipment utilization to higher ups. Again, there is another ratio about which help us to say about our decision to someone, that is the storage space utilization. So the storage space utilization means the storage space occupied and the total available storage space. If the ratio is 1, so it means you are safe. If ratio is near to 1, so again it's okay. But if it is very less than 1, so then your design is not working accurately. There is another one, the manufacturing cycle efficiency. Because the material handling equipments and systems are the integral part of manufacturing system and complete plant, so you have to directly impact the manufacturing cycle efficiency. So that's why you have to say about the machine time and time in production department, that how much time a material takes in production time and how much practically you are working as a machine on this piece. So it will tell you about the manufacturing cycle efficiency. Energy ratio. Energy ratio is another thing. It will tell you about the total BTU consumption in the warehouse and the warehouse space. So it will tell you about the per square foot how much BTU of energy you are consuming. So the complete material handling system contribution in the energy ratio, you can say about, okay, 30% is going to the material handling while 70% is being used in other utilities and in other machining processes. So it will also tell you about the energy ratio. So if you know about the energy consumption of the material handling devices and the warehouse space, then you can say that how much percent of material handling equipment are contribute towards the energy consumption inside the warehouse or inside the factory. Let's come to an example where we can say that a forklift truck initially cost $20,000 and has an expected life of 5 years. Fuel cost is $10 per 8 hours of operation, $10 for complete one shift, and maintenance cost is $1.5 an hour. If the truck travels an average of 10,000 feet per day, determine the cost per foot. Assume that the truck operates 360 days a year and the operator is paid $10 an hour. So let's come to the solution. So you can see these type of, and you have to answer, for example, if you are manager and you are working in industry, so you will answer these type of questions. So first determine the depreciation, because the truck has a specific life. So we have to calculate the straight line depreciation. We can use that simple method. You know about this from your sixth or fifth semester economics. So 20,000 divided by 5 into 1 year. In 1 year we have 360 days, and 1 day we have 8 hours. So the total depreciation cost per hour, that is $139, $1.39. The distance traveled per hour is 10,000 feet per day. and in one day we have 8 hours. So multiplying that, so 1250 feet per hour this truck is traveling. So the total cost per hour is maintenance is equal to maintenance plus fuel plus depreciation plus operator cost. So if we include, so this one is the 14.14 per hour is the total cost, but we have to calculate the cost per feet. So divide 14.14 divide by 1250. So this truck basically, when it travels, so per foot cost is $0.0113. So you can say that, okay, per foot cost for this particular truck is this much. You can also say this about for the storage equipment, that if we store something and it takes energy, so you can talk about that how many operators are working with it, what is the maintenance cost, is there any depreciation associated with that storage compartment or not. So then you can say that, okay, per square foot, because it carries square foot area, so per square foot how much is the cost. So you can, this way you can predict the material handling, storage and retrieval cost of the complete plant, not only for a single department. If you combine various departments, so you can accumulate the complete cost for the particularly this single component material handling and material storage and retrieval. Okay, now come to the end of this lecture, and this one is the assignment. Already I have given 3 assignments, and this one is the assignment 4. I will give that maybe next week for the submission of this assignment. So you have to prepare a theoretical design case of material handling system and its selection procedure. So it's a theoretical case. You choose your case by yourself and write down by hand. Don't need to write in PowerPoint or in Word. You can write down on hand and sketch, provide different sketches that, okay, this is the case. I want a theoretical design for this type of material handler. That what type you can use, maybe you can talk where the people are using manual storages. Like in shoe shop, if you go to the shoe shop, so in shoe shop, there is a storage, there is a material handling, there is a retrieval as well. So you can talk about that. That, okay, for example, that how much is the cost associated with that, and how I will select it. Whether that manual one is good, whether that is the any automated option for you. If you are choosing the automated option, so whether that is cost effective for you or not, whether the manual one is good for you. So you can discuss different alternatives theoretically. Don't need to go in very outside and search the different cases. Just think about and produce your design. So it's a case, okay? So this is a case study, and every case study will be different from another one. Write down and produce some sketches and submit it. Any question if you have?